Test 1 Review Algebra 2. Number 1. What is the value for m for 4 absolute value of m plus 3 minus 3 equals negative 3? The first step that we want to do for this one is isolate our absolute value sign. So first we want to add the constant 3 to each expression, both sides of the equation. So then we have 4 times the absolute value of m plus 3 equals 0. To continue to isolate the absolute value, we want to divide by this coefficient 4. So divide each term by 4. So this cancels out, becomes a 1, and this is a 0. So then we have the absolute value of m plus 3 equals 0. Now that our absolute value is isolated, we will write our two equations, our positive part and our negative part. So for our positive part, we have m plus 3 equals 0. And then for our negative part, we have m plus 3 equals negative 0. As you can see, these are actually both the same equation, so we're only going to get one solution here. So for both equations, we'll solve for m. Subtract 3 each side. So we have m equals negative 3. Same thing for this side, minus 3, minus 3. We still have m equals negative 3. And the last step, we'll plug negative 3 back into our isolated equation to see if it's real or extraneous. So the absolute value of m, which instead of m, it's now negative 3, plus 3. Does it equal 0? So negative 3 plus 3 is 0. The absolute value of 0 does equal 0. So that means that m equals negative 3 is a real solution. Okay, let's look at number 2. Write the attributes for the parent function f of x equals the absolute value of x. So first we will find the domain, left, right, x. So to do that on the graph, go ahead and draw two vertical lines, one on the leftmost part of the graph and one on the rightmost part of the graph. So the part of the graph that intersects the vertical lines are the arrows. So for this one, x will be approaching negative infinity, and on this one, on the right side, x is approaching positive infinity. There's no breaks in between, it's a continuous function, so that means it's all real numbers. So on our verbal description, we will write all real numbers. For our inequality notation, we actually wouldn't have one. We would just say all real numbers. But if you want to have an informal notation, it would look like this. Negative infinity is less than x and is less than positive infinity. For our set notation, set builder notation, we have x such that x is an element of the real numbers. And for our interval notation, we write what we had on our informal inequality notation. We put the smallest value on the left side, comma, our largest value on the right side. Notice I put parentheses around it because infinity is never included. So instead of a bracket, we'll always put a parenthesis around infinity signs. Now for the range, we want to draw two horizontal lines, one at the lowest part of our graph and one at the highest part of our graph. So at the lowest part of our graph, that is y equals 0. At the highest part, the horizontal line goes through the arrows. Those arrows are pointing up. They're going upwards. So y is approaching positive infinity. So for our verbal notation, we could just say that y is greater than or equal to 0. This 0 is included because this sharp point right here is included in the set. You could make a point at 0, 0. For our inequality notation, we'll write this with symbols. We'll have y is greater than or equal to 0. For our set builder notation, we'll put braces y such that y is greater than or equal to 0. And for our interval notation, we'll put bracket 0, comma, infinity. So the sharp point is the lowest part of the graph. It's a low vertex, so that is a minimum. The vertex point is at 0, 0, the origin. And for the parent function of an absolute value, the x-intercept and the y-intercept are also the origin, 0, 0. Remember that. All three of them are the same for this parent function. And your axis of symmetry is the line that goes through the vertex. That line that goes through the vertex here is at x equals 0. That is your axis of symmetry. Because if you folded the graph in half, it would have two equal parts. Number 3. Describe the transformation from the parent function f of x equals the absolute value of x. On part A, it says f of 0.25 times x plus 4. So the new slope is on the inside, so that means it's horizontal. It is a horizontal stretch by a factor of 4. And it is a horizontal shift to the left 4. So for the first one, we have a horizontal stretch by a factor of 1 over 0.25, which is also known as a horizontal stretch by 4, and a horizontal shift left 4. So the 0.25 is for the first blank, and that plus 4 is for the second blank. Remember, whenever you have something on the inside of the parentheses, on the inside of the absolute value, any of that, it's always the opposite. So instead of 0.25, it's the reciprocal, which is 4. Instead of going right 4, we're thinking it's going to go left 4. Now on part B, we have 0.25 f of x plus 4. This one will have a vertical compression by a factor of 0.25, and it will be a vertical shift going up 4. So when the new numbers or transformations are on the inside of our parentheses, it's horizontal. When our new numbers or transformations are on the outside, they are vertical. Number 4. Graph the parent function f of x equals the absolute value of x and the transformation g of x equals f of negative x plus 2 on the grid below. Then describe the transformations. So I'll put the parent function in blue. So we start at the origin and our slope is up 1 over 1. And then we do that to the other side to make a mirror image. Our new function or transformation is going to be g of x equals f of negative x plus 2. So if we have a negative on the inside like this, it's not actually going to change anything with an even graph like this. So if we were to write this out, our new transformation graph, it would be g of x equals the absolute value of negative x, close the absolute value sign, and then plus 2. And this would be the same thing as g of x equals the absolute value of x plus 2. If we're looking at a stationary graph, these two images would look the same. If the graph was moving like three-dimensionally, it would be spinning around. So the only thing that we do here, the only new thing is that it goes up 2. So we'll shift the graph up 2. The slope doesn't change and it does not reflect. Well, it doesn't reflect in a way that we could see it with just a stationary graph. So our transformations are it technically reflected across the y-axis. And then it went up 2. Number 5. You're jogging at a rate of 5 miles per hour. Here's the table. We have x, time in hours, and y, distance in miles. According to the table, write an absolute value function of the form y equals a times the absolute value of x minus h to represent the y miles from when you started your jog. So the first thing that we want to do is find our vertex. Our vertex can be found on the table by finding what point does the y values start changing direction. So we have 15, 10, 5, 0, 5, 10, 15. These 5s are the same number here, so we look for the number that's in between the same numbers. So our vertex is going to be 3, 0. Pay close attention. The axis of the vertex will not always be in the very middle of a table like this. So we know that our vertex is 3, 0. Now we want to find our slopes. So we have plus 1 for our x, minus 5 for our y's. After the vertex, it changes though. We still have plus 1 for the x, but now we have plus 5 for the y's. So our slope is going to be either plus or minus 5 over 1. To figure out which one we're going to choose, we'll go ahead and sketch a graph of these 3 points. So we have 3, 0, 2, 5, and 4, 5. So if we connect the dots, it looks like our absolute value is pointing upward, it's opening upwards. So since it's concave up, that means we're going to use the positive slope. So it's going to be 5. So this is our A equals 5. Our H is 3 and our K is 0. So we'll plug that into our formula. We have y equals 5 times the absolute value of x minus our h value, which is 5. No, not 5, 3. So we have y equals 5 times the absolute value of x minus 3. Notice the vertex's x-coordinate is the opposite of what's in the formula because we have a negative sign here. That means we change the sign of whatever the x-coordinate is. On B it says, according to the table, write an absolute value function of the form y equals a times the absolute value of x minus h to represent 13 miles from where you started your jog. So it will be the same thing here, except for now we have a specific distance in miles. So instead of y, we're going to substitute in for 13. So our equation is 13 equals 5 times the absolute value of x minus 3. Number 6. Write an equation that could be used to determine the experimental value from a lab experimental that had a ball to be dropped by 450 feet from a building with a 12.6% error in the form PE equals the absolute value of actual value minus experimental value all over actual value times 100. So from here we know that PE is the percent of error. So we'll put that PE equals 12.6. Our actual value is 450 feet. So to write an equation to be able to solve for the experimental value, we just substitute 12.6 for PE and we substitute 450 wherever it says actual value. So our equation would look like this. 12.6 equals the absolute value of 450 minus x all over 450 times 100. The reason why we're multiplying by 100 is because we're already converting it into a percentage. Number 7. The recommended weight of a soccer ball is 430 grams. The actual weight is allowed to vary up to 20 grams. Write an absolute value equation to find the maximum and minimum acceptable soccer ball weights in the form absolute value of x minus b is equal to t. So if you remember from your notes, b is representing the midpoint, the actual recommended weight in this case. So that's 430. T stands for tolerance. That's how much you can either add or subtract to that recommended weight for it to still be considered acceptable. So the equation would now be absolute value of x minus 430 equals 20. And to solve for the acceptable weights, you would just solve your two equations. Basically what happens is that you add 430 plus 20, or you subtract 430 minus 20 to get your two max and min acceptable soccer ball weights. Number 8. Solve for x. State if the solution is real or extraneous. We have negative 1/4 times the absolute value of x minus 3 plus 6 equals 5/4. So we could either get rid of the fractions first or subtract 6. For this problem, I'll go ahead and multiply everything by 4 first so we can get rid of those fractions. So 4 will be multiplied by each term, the negative 1/4, the 6, and the 5/4. Notice we don't have to multiply it by the absolute values terms inside the x and the negative 3 because the part of the coefficient on the outside of the term, negative 1/4, is the only thing we'd have to multiply here. So when we multiply that, we get negative 1 times the absolute value of x minus 3 plus 24 equals 5. So to isolate the absolute value, first we will subtract 24 for each expression, both sides of the equation. So I have minus 24 minus 24. So we have negative 1 absolute value of x minus 3 equals negative 19. Okay, the next step, we want to still isolate the absolute value, so we're going to divide each term by negative 1. So then we have the absolute value of x minus 3 equals 19. So now we're ready to set up our two equations. We have x minus 3 equals 19, or x minus 3 equals negative 19. We'll solve for x for both equations. Add 3, add 3, add 3, add 3. We add 3 to each expression. So we have x equals 22, or x equals negative 16. And for our last step, we want to check if these are extraneous or real. So to check, we look back at our isolated absolute value equation and notice that it equals a positive number. Since the absolute value equals a positive number, it's always going to be a real answer here. If this number was negative, that would always be an extraneous solution. And if it had a variable in it, you would want to plug these numbers back into this equation right here and see if it's true, a true statement, which would be a real solution, or a false statement, which would be an extraneous solution. Since these would both be true, they're both real solutions. So we'll say that x equals negative 16 and 22. And then for extraneous solutions, we would say none. The empty set. Number 9. Solve for x. State if the solution is real or extraneous. 5 times the absolute value of x plus 5 plus 11 equals 4. So the first thing that we want to do to isolate our absolute value is to subtract 11 from each expression. So then we have 5 times the absolute value of x plus 5 equals negative 7. After that, divide each term by 5. So 5 divided by 5 is 1. So we have 1 absolute value of x plus 5 equals negative 7/5. So now we've isolated our absolute value. We're going to set up our two equations and find our two solutions. So to set up our two equations, we'll have x plus 5 equals negative 7/5, or x plus 5 equals 7/5. Now from here, we want to get a common denominator. So we'll have 5 over 1. So we'll have to multiply by the unity fraction 5 over 5. And by the unity fraction 1 over 1 to get the common denominators. So after you do that, you have x plus 25 over 5 equals negative 7/5, or x plus 25 over 5 equals 7/5. Subtract the 25 over 5 from each expression. So we have x equals negative 32 over 5, or x equals negative 18 over 5. Now we're going to check for extraneous. So going back to our absolute value that's isolated, notice that it equals a constant that's negative. Absolute value expressions can never be negative, so these would both be extraneous solutions. So our real solutions are none, the empty set. And our extraneous solutions are x equals negative 32 over 5 and negative 18 over 5. Now if it just asks for solutions and not real or extraneous, assume that they're only wanting real solutions. Number 10. For y equals 6.5, which equation would best represent the graph? So we have 4 answer choices here. Before we look at the answer choices though, let's go ahead and make an equation from this absolute value function. The first thing we want to do is find the vertex. This vertex point is negative 2, 6. Because notice each square is going by going by 2's. Negative 2, negative 4, negative 6, negative 8, negative 10. Same thing with the y-axis. The next thing you want to do is find the slope. So we'll take 2 lattice points and draw a triangle. It's rising 3 and each square represents 2. And it's running 3 squares and each square represents 2. So if we have 6 over 6, rise over run, that is going to be 1. So we have a vertex of negative 2, 6, and their slope is either plus or minus 1. We're going to do negative 1 because the graph is opening downwards. The absolute value is opening downwards. So from here, we can plug in our found values into our formula. Y equals A times the absolute value of x minus h plus k. So our A is negative 1, so I have a negative sign x minus h, which is negative 2, plus 6. A negative times a negative is a positive. So we have y equals negative 1 times the absolute value of x plus 2 plus 6. And that's our equation for this function. Now from here we can eliminate some choices from this. So we know that it's going to be negative, so it can't be this one and it can't be that one. Our vertex right here is negative 2, 6. This one is not that. This has a negative 6. Has to be the first one. The 6.5 is to be substituted for y, since it says that in the question. Y equals 6.5. So that's another reason why it couldn't be the third choice. And if you're ever not sure and you have a graphing calculator like Desmos, you could graph this function right here and see if it's the same or different as the picture you see here. Number 11. Solve for x. If you get all real numbers, you'll put the set of all real numbers. If you get all extraneous solutions, put the empty set. The set of nothing. So we have 5/6 times the absolute value of x plus 4 minus 1 is less than or equal to negative 4. So the first thing we want to do is isolate the absolute value. Let's multiply everything by 6 to get rid of that fraction. So multiply each term by 6. 5/6, negative 1, and negative 4. When we do that, we get 5 times the absolute value of x plus 4 minus 6 is less than or equal to negative 24. From here, we want to add 6 to each expression, both sides of the inequality. We get 5 times the absolute value of x plus 4 is less than or equal to negative 18. From here, we want to divide each term by 5. So 5 times the absolute value of x plus 4 divided by 5 is just 1 absolute value of x plus 4. So we have the absolute value of x plus 4 is less than or equal to negative 18/5. Now, we could stop here actually, since we know that absolute value can never be less than or equal to a negative constant. So this would be the empty set, all extraneous solutions. Now, we'll go ahead and move on to this so we could just see what those two extraneous solutions would be. So once we set up our two inequalities, we want to subtract 4 from each expression. We can't subtract the 4 right away, so we have to get a common denominator. Negative 4 is the same thing as negative 4 over 1. So to get a common denominator, we want to multiply the 18 over 5 fraction by the unity fraction 1 over 1. And we'll multiply the 4 fraction by the unity fraction 5 over 5. and then we'll rewrite our inequalities. So we have x is less than or equal to negative 18 minus 20 all over 5, or x is greater than or equal to 18 minus 20 all over 5. And then we would combine like terms at the top in the numerators to get, so we simplify those. You get your extraneous solutions. X is less than or equal to negative 38 over 5, or x is greater than or equal to negative 2 over 5. The answer that they want for this case, though, is that they're all extraneous. There's no real solution here. So you would have the empty set as your selected answer. Number 12. Graph f of x equals the absolute value of x. Graph its transformation. G of x equals negative absolute value of x plus 2 plus 6. Describe the transformations. So first in blue, I will graph the parent function f of x equals the absolute value of x. And then for the transformation, the negative means that reflected across the x-axis, so it's going to be opening downwards. The plus 2 means that it goes to the left 2 units, and the 6 means that it goes up 6 units. 1, 2, 3, 4, 5, 6. And then the slope is basically the same. It's still 1. Negative 1, positive 1. So here is your new graph. And then the transformations was it reflected across the x-axis. It went left 2, and it went up 6. And you could also graph this on both of these functions on Desmos to see your graph picture as well. So from the blue to the red, it reflected, it went left, and it went up. Good luck on your first test.